It's an AIPMT 2000 question. The question is like this. A particle of mass 1 kilogram is thrown vertically upward with a speed of 100 meter per second. After 5 seconds, it explodes into two parts. Let me pause there for a second and tell you that discuss about that part of that, right? A particle is initially in the state of rest whose mass is 1 kilogram thrown vertically up with a speed of 100 meter per second. After 5 seconds, so I assume this is the journey for which it has traveled for 5 seconds. Before it exploded into two pieces, let me find the velocity of that 1 kilogram block itself, right? So after 5 seconds, V equal to, I can use the formula U plus AT, as you know. U is 100, he has given it for you. A is minus G because it is going upward and gravity pulls it in downward direction, into T equal to 5. As all the numbers and the options are round figures, you can safely consider G value as 10. 100 minus 50, 50 meter per second. So just before the explosion, the body of mass 1 kilogram is moving up with a velocity of 50 meter per second. That's the first sentence. Let's go to the problem again. One part of mass 400 grams comes back with a speed of 25 meter per second. So there are two pieces, out of which one piece of mass 400 mass grams means 0.4 kilogram comes down with a speed of 25 meter per second. Automatically there is another piece of 0.6 kilogram because totally it is 1 kilogram. How does this other piece moves? Whether it moves upwards or downwards, we have to find out. I can apply conservation of momentum in solving this problem. Let's apply that. Initially, the whole 1 kilogram, this is after 5 seconds, is moving up with a velocity of 50 meter per second, out of which 0.4 kilogram is coming down with 25 meter per second. Let me apply the conservation of linear momentum, that P initial equal to P final. P initial means mass into initial velocity. Mass is 1 kilogram, initial velocity is 50 meter per second. I will take plus J. I will consider upward as plus J, so that downward becomes a minus J. That's the P initial. P final is two pieces, right? One piece of 0.4 kilogram is moving with 25, but I will write minus J because it is said that it comes back. That means it's coming down. So I have written minus J plus other piece is 0.6. In which direction it moves, I don't know. So I'm just writing an X. That implies, simplify this, 50J equal to minus 10J. 0.4 into 25 is 10 plus 0.6 into X. This minus 10J when it comes to other side becomes a plus 10J. 50J plus 10J equal to 0.6x. 60J by 0.6 is X. That implies velocity of other piece is 60 by 0.6 means again 6 by 10 plus J. This is 10. 10 and 10 is 100. I got plus J meter per second velocity. When I say plus J, it means it is moving upward. So my answer is 100 moving upward. So answer is 100 moving upward. All other options are obviously wrong. That's how we have to solve the problem using conservation of linear momentum. Thank you for watching.